Welcome to the lesson on probability, a theoretical approach. At the end of this lesson, you will be able to distinguish between experimental and theoretical probability. You will also be able to calculate the theoretical probability of an event. Meet Mr. Gamerman, the biggest fan of board games in the whole world. From Ludo to Monopoly, he loves them all. There is one thing Mr. Gamerman hates about all board games. That is, trying to get a 6 on the first roll of a die. He always seems to roll a number other than 6, but he always wants to get a 6 on the first roll. What are the chances or probability of him rolling a 6? Mr. Gamerman is determined to find the answer. He performs an experiment in which he rolls the die and records the number he gets each time. To get reliable results from his experiment, Mr. Gamerman rolls the die dozens of times. No, make that hundreds of times. Actually, make that a few thousand times. As per Mr. Gamerman's experiment, the total number of throws of the die is 4,000 and the number of 6s rolled is 640. Divide the number of 6s rolled by the total number of throws. That is 640 divided by 4,000. The result obtained is 0.16, which is equal to approximately 1 upon 6. This is the probability of getting a 6 on the roll of a die. Since the probability is based on the observations of an experiment, it is called an experimental or empirical probability. Like Mr. Gamerman, many people across the globe have performed such experiments in the past. The experimental probability in most cases settles around 1 upon 6 or 0.16. Now, let's analyze the activity of rolling a die. A die when rolled will always show a number from 1 to 6. Here, we'll assume that the die is fair or unbiased. This means that if Mr. Gamerman rolls the die, then all the numbers from 1 to 6 have an equal probability of showing up. The possible outcomes when the die is rolled are 1, 2, 3, 4, 5 and 6. These outcomes are said to be equally likely. Thus, the total number of possible outcomes is 6. Out of the total number of possible outcomes, how many are favorable? By favorable, we mean how many possibilities allow Mr. Gamerman to get a 6. Clearly, there is only one such possibility when the die rolls a 6. Thus, there is only one favorable outcome. Therefore, the probability of getting a 6 on the roll of a die is the number of favorable outcomes divided by the total number of possible outcomes. In this case, it is equal to 1 upon 6, which is equal to approximately 0.16. This is called theoretical or classical probability. So now Mr. Gamerman's mind seems to be at rest. He now knows his chances of getting a 6. Please note that as the number of observations in an experiment increases, the experimental probability gets closer to the theoretical probability. Let's move on to learn more about calculating theoretical probability. The theoretical probability of an event E, denoted by P of E, is given by the number of outcomes favorable to E divided by the total number of possible outcomes. Now, observe the total number of possible outcomes when you roll a die. Each of these outcomes is called an elementary event. Now, let us investigate the probabilities of all the elementary events of rolling a die. The probability of getting the number 2 on the roll of a die is 1 by 6. The probability of getting the number 5 on the roll of a die is again 1 by 6. Similarly, we can show that the probability of getting any number 1, 2, 3, 4, 5 or 6 on the roll of a die is 1 by 6. What does this indicate? This indicates that the sum of the probabilities of elementary events of an experiment is 1. Now, let us get back to the probability of getting the number 1 on the roll of a die. As you already know, the probability of getting the number 1 on the roll of a die is 1 by 6. Now, let's consider another event. What is the probability of getting a number other than 1 on the roll of a die? The total number of possible outcomes when we roll a die is 6. In this case, the number of favorable outcomes is 5. Thus, the probability of getting a number other than 1 on the roll of a die is 5 by 6. That is, represent this event as 1 bar. Now, let us compare the probabilities of the last two events. Note that you cannot get 1 and a number other than 1 at the same time when you roll a die. The two events 1 and 1 bar shown here are mutually exclusive. That is, the events can only happen in the absence of each other. Such events are called complementary events. The sum of the probabilities of two complementary events is always equal to 1. Now, let us find the probability of getting the number 10 on the roll of a die. As you know by now, the total number of possible outcomes when you roll a die is 6. How many favorable outcomes are there on getting the number 10? Clearly, it is 0, since a die only has the numbers 1 to 6. So, the probability of getting a 10 on the roll of a die is 0. An event having 0 probability of occurrence is called an impossible event. Next, let's find the probability of getting a number less than 10 on the roll of a die. As you know by now, the total number of possible outcomes when we roll a die is 6. A die can show any number from 1 to 6 and all of them are less than 10. Thus, there are 6 favorable outcomes to rolling a number less than 10. The probability of getting a number less than 10 on the roll of a die is 1. An event having a probability of 1 is called a sure or certain event. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. The theoretical or classical probability of an event E, denoted by P of E, where P of E is equal to the number of outcomes favorable to E divided by the total number of possible outcomes. Here, it is assumed that the outcomes of the experiment are equally likely. The probability of a sure event or certain event is 1. The probability of an impossible event is 0. The probability of an event E is a number P of E such that 0 is less than or equal to P of E, which is less than or equal to 1. An event with only one outcome is called an elementary event. The sum of the probabilities of the elementary events of an experiment is 1. For any event E, P of E plus P of E bar is equal to 1, where E bar stands for not E. E and E bar are called complementary events. Experimental probability gets closer to the theoretical probability as the number of observations increase. Hope you enjoyed this session.